Okay, good morning, all of you. Can you hear my voice? Is it audible? Katong sa TM. Good morning, all of you. Can you hear my voice? Is it audible?
Yes. Yes, sir.
Okay. Okay, let's start the last unit, unit number 7. Unit 7. This is the multiple access technique for mobile communications. First, what is multiple? Multiple is more than one. Okay, more than one access technique. More than one access technique means if or more than one users, mobile users trying to access the wireless communications, cell communications. So we need a technique. We need a multiple access technique to serve multiple users, mobile users. So this is called the multiple access technique for the wireless communications. Wireless is the name implies that there is no physical connectivity in the wireless. So this is the air-to-air communications. But if there is no physical connections, then if we have multiple users, so we have to have the uh, technique to serve the services. So in wireless communications, it's often desired to allow the subscriber means that the mobile users who is accessing the services of cell, okay, cell phone, cell services, to send information simultaneously from the mobile phone to the base stations, while receiving information from the base stations to the mobile stations. So transmitting and receiving, okay, transmitting and receiving of the mobile stations data. Sometimes we transmit and sometimes we receive the informations. So this is the multiple access introductions, and one more introduction is the a cellular systems divide any given area into a cell. Okay, let's here in our last image also cellular. Okay, in our last class also we discussed about this cellular. Okay, there are some cell that it feed the informations. Okay, it feed the it feed the receiving and transmitting by the base station or maybe the MSC. So a cellular system divide any given area. So we have a given area into a cell where a mobile unit in its cells communicate with the base station. So mobile stations or mobile phones can access the base stations or base station subsystem. The main aim is the cellular system design is to be able to increase the capacity of the channel. So from the uh, BTS based terminal stations, or the towers having the capacity of the channel to handle as many call or as possible in a given bandwidth. So there are some frequency bandwidth allocation, frequency capacity allocation channel from the cellular system, from the BSS, base station subsystem, uh, base station or a BST, so BTS, base terminal station, to handle those calls. Okay, calls with a sufficient level of quality of services. So for doing this, we need multiple access. Let's see the first one, how to give multiple access to the users, subscribers. The first one is the frequency division multiple access. In this frequency division multiple access, FDMA, frequency is the basic technology for advanced mobile phone services. The features of this frequency division multiple access are: FDMA allows a different subband of frequency. So in this frequency division multiple access, we have a subband of the frequency. Let's see here in this frequency division multiple access, here we have a time, and here we have a different types of frequency from the maximum bandwidth. Or here, let's see in this is the time, this is the frequency, and from here up to this is our frequency bandwidth allocations, and it's divided these frequency allocations into two, okay, like 12.5 kilohertz and 12.5 kilohertz, okay, and in between this we needed to have a guard band sometimes, okay, for protecting the interference between the two channels, between the two frequencies. So this is the technique of this FDMA, frequency division multiple access. In this FDMA, a different subband of frequency to its different user to access the network. If FDMA is not in use, the channel is left idle instead of allocating to the other users. So this is the one of the advantages of this frequency division multiple access. If the channel is not used by the users, then it's kept idle. It's not allocated to other users. So this is unused channel. Efficiency is very less if there is no users in the frequency allotment. Then the frequency is waste. Okay, it's not used. FDMA is implemented in a narrow band system, and it is less complex than time division multiple access. So frequency division is more simple to implement as compared to the time division multiple access, and it's handled by using this narrow band system. What is the narrow band? Narrow band technology. Narrow band refers to the data communications and telecommunications tools, technologies and services that utilize a narrower set of band of frequency in the communications. These utilize the channel frequency that is considered flat or which will use lesser number of frequency set. So narrow band means a narrow set of band of frequency in the communication channel. So narrow band means it slices up all these frequencies. Okay, it slices up from the channel allocations. Let's see in our previous picture here. So here each and every frequency allocations in the narrow, okay, narrow allocations. Let's see, this is also the frequency. Here we have a time this frequency allocations from here up to this is the whole bandwidth, and it's split up into the multiple of frequency splitting up, and all these are in the narrow band. Okay. Okay, and tight filtering is done here to reduce adjacent channel interference. Okay, tight. So we need to have a tight fittings to achieve more channel and also to reduce adjacent channel interference. The base stations BS and mobile stations MS transmitted and received simultaneously and continuously using this FDMA, frequency division multiple access. Okay, this okay we is completed this FDMA. Let's go to the spread spectrum multiple access. Under this SSMA, spread spectrum multiple access, we have two types: frequency hopping spread spectrum and direct sequence spread spectrum. This SSMA uses single which have a transmission bandwidth whose magnitude is greater than the minimum required RF bandwidth. So the magnitude, transmission bandwidth magnitude is greater than the minimum required radio frequency bandwidth. Okay, RF bandwidth, we have our radio frequency bandwidth allocations. This is the whole channel bandwidth allocations in the radio frequency. So the transmission bandwidth, okay, in this SSMA use single which have a transmission bandwidth whose magnitude, the magnitude is greater than the minimum required RF bandwidth. So for achieving those things, we need to have a two type of technique. Number one is frequency hopping spread spectrum and direct sequence spread spectrum. Let's see in this frequency hopping spread spectrum. This FHSS is a digital multiple access system in which the carrier frequency of the individual users are varied in a pseudocode fashions, pseudo-random fashions, pseudo-random fashions within a wideband channels. So in this frequency hopping, let's say uh, different types of frequency hop in this. Different types of frequencies are there. In this example, here we have a signal amplitude, and here we have a time given in each and every slot. We have a frequency, okay, then the amplitude is there. So each and every time of the frequency, we have a hopping of the frequency. Okay, we have a hopping of the frequency. Let's see in this spectrum that here we have a first hop frequency. In this first hop frequency, then the qubit pattern is this one. Okay, qubit pattern of this one. So let's see here in this, what is the use of this pseudo-random fashions. Okay, pseudo-random fashions means we have a random of frequency within the wideband channels. We have a wideband channel, total wideband channel here. Wideband time, frequency, locations, and the power in this frequency wideband allocations. Then each and every channels having this pseudo-random fashions within the wideband. Okay, the digital data is broken into a uniform burst, size burst, which is then transmitted on different carrier frequencies. So within this desired signal hop counts, then the digital informations are sending to each and every users. Okay, this is called the hopping. Okay, hopping of the frequencies. And the next one is the direct sequence spectrums. Spectrum, DSSS, DSSS. This is the most commonly used technology for CDMA. Okay, code division multiplexers. In this DSSS, the message sent in a multiplied. The message signals. All those message informations are multiplied by the pseudo-random noise code. So it's having the pseudo-random code in this. Here we have a code, and here we have a user data, and these two are multiplied. Okay, then it's transmitted these signals. Okay, see here in this spectrum, spectrum. Okay, in this we have a transmitted signals. Okay, so from this we have a user data, so it's multiplied these signals. Okay, it's multiplied the informations. Using this pseudo-random noise code, this is the code, and it's multiplied with the message. Each user is given this own code what? So the name itself, that code division multiple access in this direct sequence, is having its own code what? Which is orthogonal to the code of other users. Because this is orthogonal to code of the other users, and in order to detect the users. So each and every user have its own code. Okay, the receiver must know that the code word used by the transmitters. Okay, and receiver knows that, oh sorry, the transmitter knows that the receivers which code word is using. Okay, this is the direct sequence spectrums. Okay, spectrum D triple S. The important point is D triple S, this direct sequence use CDMA, and moreover it's multiply the message with this pseudo random noise code, and each users is given his own code word which is orthogonal to the code of other users in order to detect the users by the receivers. Okay, and let's move on to the next code division multiple access. We already see in our last point of the spectrum multiple access, this code division multiple access. Code division multiple access technique is the example of multiple access where several transmitters use single channel to send information simultaneously. So the code division multiple access technique is an example of multiple access. So several transmitters use single channel to send information simultaneously. The features of this CDMA is that every users use the full available spectrum in this code. In the graphic, so in this CDMA code division multiple access, each and every frequencies from the bandwidth, okay, allocations, okay, bandwidth locations, it's having the code, okay, from the amplitude, but from the time, let's see, it is fully allocated, okay, for the particular user. There is no slicing and all. This is the frequency bandwidth, the full bandwidth allocated in this code based on the amplitude. Okay, based on this amplitude. So every users use the full available spectrum instead of getting allocated by the separate frequency. And point number 2 is CDMA is much recommended by voice and data communications. So it is good for voice and as well as data communications. Why? That use the full available spectrum. And while multiple access occupy the channel in the CDMA, the user having the same code can communicate with each other. So it can have the same code while it's used the channel. Okay, there is no separate users. So the channel is having this code. Okay, then it can reuse it. The user having the same code can communicate with each other, so it's having the same code. CDMA offer more airspace capacity than TDMA, time division multiple access. Let's see here in this TDMA in this time frequency time, first time, second time, third time. So each and every time we have a slot. Okay, we have a slot. This is time division multiple access. Each and every time we have different types of frequency in this frequency division multiple access. But in the code division multiple access, the full time is allocated by the users. There is no slicing in the time. There is no slicing in the frequency. It can use the full spectrum, okay, full bandwidth, and it's having the code for accessing this one. So that's only, this is the advantages. So it's very good for this data communications and voice communications. Okay, CDMA offer more airspace, okay, more airspace capacity, so then time division. There is no slicing, then it's fully allocated, so we have more space capacity. The handoff between the base station is very well handled by the CDMA. So handoff technique is very smooth and fast in this code division multiple access. No need to have the separate channel allocations in the CDMA. Why? While multiple code occupies the same channel in the CDMA, the user having the same code can communicate with each other. So it's using the same code from each and every cell. So handoff technique from one cell to another is very smooth and easy in this code division multiple access. Sorry, CDMA. And move on to the hybrid spectrum technique. Code division multiple access technique is an example of multiple access where several transmitters use single channel to send information simultaneously. So it's used the single channel, there is no time slice, there is no frequency slice, so it's using this single channels to send information simultaneously. And its features as follows. CDMS, in CDMA every user uses the full available spectrums instead of getting allocated by separate frequency, so it's used the full spectrum. CDM is much recommended for voice and data communications. So sorry, it's repeated. Okay, in this it's repeated, this one in this. Okay, let me see this hybrid. Okay, I'll make some mistake here. It's repeated the slides, that's why. Okay, hybrid spread spectrum systems, which is a combination of this direct sequence DS and frequency hopping and spread spectrum techniques. So all this combination is called the hybrids, are attractive for their strong multiple access capabilities, resistance to the multi-path fadings and intentionals and unintentional jammings, and the security they provide against avast dropping. So the advantages is that it's combined all those techniques, okay, all those techniques in this hybrid. Then it resistance to multi-path fading. Last class we already explained what is multi-path fadings, and intentional and unintentional jamming of the signals, and also avast droppers of this security. If someone try to intercept the signals or something like this, then it's have a resistance of this in these hybrid spectrums. Okay, let's move on to the space division multiple access, SDMA. Space division multiple access, or the spatial division multiple access, is the technique which is the multiple input multiple output MIMO architectures, and used mostly in wireless and satellite communications. So space division multiple access name depicts that it's having a separate control of particular space, particular area, not covering this cell type or these things. It have a beam of focus of this some particular space or area. This is called space division multiple access. It is a technique with this multiple input and multiple output MIMO architectures, and used mostly in the wireless and satellite communications. In wireless communication and satellite communication. In this satellite communication also, it's having some focus area in from the satellite, some region. So let's see in this graphics here. In this SDMA, space division multiple access, from this device it cover some area, some space. Okay, outside this space it cannot access the informations, unlike omnidirectional antenna. So omnidirectional antenna is cover the whole space, okay, 360-degree. Unlike this omnidirectional antennas, smart antenna are used to form a beam and serve only a certain area. So it covers some certain spaces or some certain area where the user is at the moment. With users' mobility even in the beams has to be adapted. Reduce of multi-part problems. So there is no multi-part in this cellular techniques. We have a multi-part, maybe from the towers, or it's maybe from the reflected area, reflected by the buildings or a tree or any other objects. So if it's reached to the mobile stations, then it detects multiple signals, duplicate signals, okay, from the multipart. So this space division multiple access reduce the multipart problems. Why? It's focused. Okay, it's focus certain area. The beam focus certain area or certain spaces. Then it's reduce the multipart problems. So as DMA is combined with this frequency division, time division, and CDMA to distinguish between user in a same beam. So very cost intensive. There exists already 2D, 3D antenna pattern. Okay, 2-dimensional or 3-dimensional pattern of this antenna. So this is the technique of this space. Okay, all users can communicate at the same time using this same channel. So in this space divisions, it's cover some particular area. So from this space, from this area, all users can communicate. Okay. SDMA is completely free from interference. Okay, there is no interference from space to space. There are some free area between the space division multiple access. A single satellite can communicate with more satellite receivers of the same frequency the omnidirectional directional spot beams antenna are used, and hence the session is SDMA can track moving user, control the radiated energy for each user in space. Okay, these are the thing in this multiple access of different type. Next class we are going to this radio packet radio protocols. This is for this multiple access technique. Okay, different multiple access technique.